All right, let's take a look at some basic trig identities. Some of them I talked about in a previous video. Probably one of the most easiest and most commonly used identity for tangent of theta. Tangent is nothing more than sine theta over cosine of theta. So whenever you have a tangent, you can always trade that in for sine over cosine. And then, of course, secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine of theta. Some very, very basic identities. Now, that leads to the Pythagorean identity, which is sine squared of theta plus cosine squared of theta equals 1. This comes in extremely handy. And every now and then you need to make, or you may need to algebraically manipulate this, because clearly that implies that sine squared of theta, if you need it, is 1 minus cosine squared of theta. More typically, you'll see something like this and want to go in that direction. Although the other direction is clearly possible, and it may come in very handy. And also, this clearly implies then that cosine squared of theta is then equal to 1 minus sine squared of theta. Now, a couple more identities that come in handy. 1 plus cotangent squared of theta is equal to cosecant squared of theta. And that obviously implies that cotangent squared of theta is cosecant squared theta minus 1. And tangent squared of theta plus 1 is equal to secant squared of theta, which implies that tangent squared theta is equal to secant squared theta minus 1. Now, these identities is something that you really should memorize. And really, if you remember this, then you can come up with these. If you remember this, then obviously you can get that. If you remember this, then obviously you can get that. So I don't know if I necessarily memorize all of them, but I would memorize these pieces, because from these pieces you can get to any place else that you need to go to. Double and half angle identities. There's a couple of them that pop up an awful lot. Here's one that you will see quite a bit. Sine of 2 theta can be written as 2 times sine theta cosine theta. This does pop up every now and then. And then, of course, you have cosine of 2 theta, which you can write as nothing like that. It's cosine squared theta minus sine squared theta. And then the two biggies you see, or probably have already seen a lot in integration, is cosine squared of theta equals 1 plus cosine 2 theta over 2. Very commonly, if we need to integrate a cosine squared, we'll work with this identity, because this is very easy to integrate. Cosine squared by itself can be a little bit confusing. And sine squared theta has a similar identity. This is 1 minus cosine of 2 theta divided by 2. This most commonly pops up. We're trying to integrate something and you have a sine squared in there that you need to integrate by itself. It's kind of like, well, how do I integrate that? Using this identity makes it pretty straightforward.